This is the Amp Hour Podcast, recorded November 4th, 2015. Episode 274. The Amp Hour's first call-in show.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
And it feels like episode 1 again.
It does. We're like nervous. We're giddy like schoolboys right now. It's
We're just jumping in, both feet.
This is going to be terrible. We'll see.
Kicking and screaming.
Yeah.
We're attempting to do a live call-in show today, something completely different. Right. Although something we've talked about since day one, I think.
Well, so actually it's been about 1 year since Tom Maglioli, I forget how to say that, Tom and Ray from the Car Talk, so Tom passed away about a year ago. And this wasn't really, it's just kind of coincidence, but yeah, we're trying a Car Talk style call-in show, and but we're not airing it live.
Except for the people who call in. If you call in live, you can actually listen to this, but there's no point telling you that now because you won't hear it until you have to follow us on Twitter. If you're not following us on Twitter, you don't find out about this sort of stuff. So, yeah. Right.
And so I've had a couple other people send me the link of, oh God, what's his name? The guy who plays Tobias Funke in Arrested Development. It's from Mr. Show. There's this spoof show about about a pre-recorded call-in show, and it's like people are always calling in from the week before. I'll post a link to it. It's really funny. Okay. But yeah, pre-recorded call-in shows are kind of redundant, but it's to get we don't want to be too pre-canned. We don't want to prepare. God no.
Well, let's see how it works. See, it could be a complete and utter flop because nobody could call in. In that case, it's just us.
That will be the interesting point if anyone actually does call in.
Right, or maybe Randy can call in from.
Oh my God, like legit Randy, not Dave as Randy.
Yeah. And on the line to help us out, we actually have a producer. Woohoo!
Yes, producer.
The Amp Hour producer, Gary.
Yes.
Can we put Gary on?
We can. All right.
Here we go. The magic of the interwebs.
Yes. Hey, Gary, how you doing?
Hi there. I'm doing great. And you guys?
Good.
We're nervous as hell.
Yeah. But, we're a little nervous.
No. And tell us where you're from, Gary.
Okay, I'm from Paraguay in South America.
We've really got an international show. Paraguay, that's wedged between Brazil and Argentina? Is that right?
That's exactly right.
Somewhere?
Yep. In the middle of South America.
Oh, there you go. Middle of South America. Wow. Awesome. How's the internet there?
It's great. We have some connection. It's very expensive, but yeah, it's good.
Excellent. Can't be as expensive as Australia. I'm paying 440 Australian dollars a month for mine here at the lab.
Yeah, that's a bit much. I pay like $40 or something.
Oh God!
Yeah, that's not bad at all. Go away. Well, so Gary was helping me test this last night too, and so Gary was very nice to volunteer and help us out with call screening, stuff like that. So people who call in will talk to Gary and kind of give their particulars to him. But Gary actually works on ROS, Robot Operating System, which
awesome.
Yeah. So Gary, why don't you tell us about that a little bit, real quick?
Okay, so I work for an Argentinian company actually that is called Ecumen. And we do software development for robots. We use ROS as our main tool. And yeah, we have a lot of clients in the US and Canada and stuff. And we do basically software development for their robots using ROS.
And so what is the base language of that too? That's the thing. I've heard about it. I know it's on the PR2, which you have a picture. Your Twitter picture is of you, even though you're not working on that directly. You said. But what is it all Java or is it all C? What is ROS actually like? What's the base language and how's it all put together?
Okay, mostly it's in C++. That's the core of it at least. But you have libraries, so you can program it in Python, in C++, in Lisp. There are some work on the Java side also.
Oh, cool. Okay.
There you go. Software stuff we have no idea about.
And robots.
I also,
And robots, right?
I also do electronics. Yeah. So I'm actually an electronic engineer. So I do basically robots. I do small, cheap robots for teaching children electronics, programming, and robotics. So yeah, that's
awesome. I'd love to do something like that if I had the time.
Yeah.
We've obviously got a big delay here. I wonder where the delay is coming from. If people don't know, we're using callinstudio.com, that's what we're doing this whole thing with. And, some of it we're still using Mumble. So we're using a mixture of Mumble. We're recording locally as well. And we're using this call-in studio thing to handle all the call-ins. And we've got a toll-free number and all sorts of things. So there's obviously some sort of delay somewhere. It's I'm not sure what.
Yeah, I think it might be at the actual switch level. So I'm not sure. I mean, we're kind of traversing a bunch of undersea cables. Obviously, we're all over the world here, but it's interesting because we're going to be having. I mean, people can call in from actual telephones as well, which is kind of different. So.
I tell you what, if somebody calls in from a phone booth, an actual phone booth, you get priority. You get straight on.
Yeah.
I want someone to call in from a phone booth. Anyway, so should we give it a go? Should we try it?
I think we're ready.
Is anyone going to call in?
I think the main piece here is whether or not people are going to actually call in. I kind of feel like it's going to be like. Do you ever hear those public radio funding drives? You know what I'm talking about?
I'm going. Yeah, right. Yeah.
They're like, right. Well, we're just waiting for another call here.
Yeah, exactly.
Call on in today. We're waiting.
Hey, we've got one. We've got one.
Operators are standing by. So.
And we can see their number, can we?
Yes, but we will never read. We'll never read the number.
We'll never read your
the
number
other interesting
out.
thing about this too. So I was trying to figure out what this is all kind of using. I think this is using Twilio on the back end, which is it's basically like a AWS or like web services type thing, but just specifically for voice. So it's all cloud based type of thing. Right. Yeah, it'll be interesting to see how it actually works out. But the idea is that Gary will be able to, people will call in, they'll hear a welcome message, they'll talk to Gary, give him some of their particulars, and then we'll be able to click through and actually accept callers and stuff like that. So,
all right. Well, let's see. I guess. So thanks, Gary, for.
Oh yeah, that as well. Yes.
Thanks, Gary, for doing this. So Gary will, I guess, leave us now, will he?
No, well, he'll be doing that stuff. So
he'll be doing it in the background.
Right.
But
exactly.
We won't hear him. He'll be beavering away in the background talking to our callers.
Right. Exactly. So it looks like we do have our first caller. Are we ready? Are we ready to talk?
And we have details.
Our first caller. Yeah. This is weird.
It's Richard.
Yep.
First cab off the rank from Vancouver. Oh, not a Yank. Yes.
Hi, Chris. Hi, Dave.
Richard, welcome to the Empire. How you doing?
I'm good. How are you guys?
Hey, Rich.
Yeah.
Or is it Dick?
It's Richard.
Am I allowed to call you Dick?
No.
No, it's Richard, is it? Okay. Right. No worries. Some people like to be called Dick.
Sure, Dave. Sure. Okay. Yeah. Cool. So I'm working on that.
Yeah. Right.
Yeah, I'm working on a battery-powered device that's going to be used in pretty close proximity to 10 to 50 kilovolts, kind of the voltages you'd see in a substation. And I'm pretty concerned with protecting the circuit from induced voltages, especially the sensor's input, or from the sensors.
Okay. Well, if you're talking about inductive coupling, you want to keep your loop areas small.
Yeah, okay.
That's one. But you're only talking like 50 hertz, aren't you? Like substation,
yeah, exactly.
50 hertz
yeah,
kind
50,
of.
60 hertz-ish.
Whatever, 60 over there, right?
Yeah.
Right. So you're probably more worried about capacitive coupling. I get perhaps.
I'm kind of concerned with not necessarily keeping the loop area small. More, I know that there's going to be induced voltages and mitigating the risk, basically. Kind of like I would expect to be able to, use some diodes to the rails or something, but I'm not sure if that will or won't. Honestly, I haven't tried, but
right.
assuming that it does get coupled.
Could you tell us a little bit more about the application too?
Yeah, I was going to say, is it digital? Is it low level analog? What?
It's
that
low
makes a
level
huge
analog
difference.
sensor, but going to purely digital from then on. So going through an ADC and so on.
Well, you obviously want your ADC as close as humanly possible to your sensor. So get it straight into digital as soon as you can. I mean, that's the obvious,
Well, so the whole thing's battery powered though. So is it the whole thing's floating? Is it possible the whole thing will be floating on top of that 10.5 kilovolts? Is it are you worried about just like the transients and the fast drops?
Yeah, exactly.
Oh, so you're saying it's actually connected to it, is it?
Oh, no, it's not connected at all. It's completely separate battery-powered device.
Okay, right. So it's completely isolated. Okay.
Yeah,
yep.
Just because the voltages will be swinging so vast, I'm pretty concerned with just nuking all the poor little digital electronics there.
You're the man here, Chris, because you come from ABB. You're a power man. See, whereas I'm not a power man. I'm a low level, low signal guy. Anything over 12 volts DC scares the shit out of me.
Yeah, that's pretty much where I'm at as well. So I'm kind of okay.
Maybe 24.
Yeah, that's a healthy fear, guys. I mean, really, that's really healthy.
It's kept me alive so far.
I would say that the main thing though is the swing shouldn't be too big of a. As far as I know, the swing shouldn't be too big of a deal unless you have. First off, if one part of the circuit is ground referenced, outside of the rest of the circuit, because then that will create these huge voltage differentials. And then that whole huge voltage differential, of course, the current's going to find its way through somehow. But I'm not sure if the whole thing's floating.
The whole thing's floating. I think it's all about if there's any transients, because I think normal state should be fine. I mean, if you're just in a substation and you're talking, 50, 60 hertz, unless there's, some sort of massive transients that create massive EM fields, then, I don't think there's going to be a problem.
Okay.
Something would be going horribly wrong. You probably wouldn't want to be standing there, pressing buttons on your product. I wonder, we really need somebody who designs stuff into substations like that. Like, I've been into a substation before looking at some electronic, looking at stuff in there. It didn't seem to be any particular, anything special. They were just using regular off-the-shelf industrial PCs and, off-the-shelf, touch panels and stuff. It didn't seem to be a big deal. So I think you're going to be fine.
Okay, that's great to hear.
Of course, once again, Chris, we're talking out our ass, aren't we?
Yeah, I don't know. How do we do do we have to do like a legal statement now? Like, usually people are, it's so
Right.
It's so one-sided, It's like, oh, well, yeah. Hope no one follows
I've got
this.
to ask, what is this thing actually measuring? What are the sensors doing? I'm just curious.
It is actually measuring the electric field around the cables or whatever devices is nearby.
Oh.
So it is.
Oh, right.
It's not inductively coupled. It's more or less an electrometer.
Yep.
Okay.
In that case, yeah, I'd be more concerned about actually protecting your analog inputs than the rest of your power rails and your digital stuff and things like that. I wouldn't be the least bit concerned about that, unless you're operating down at the bleeding edge, 0.8 volt rails.
No, nothing like that.
That's ridiculous. 5 volts. Be a man. 5 volts all the way.
I would say the best advice here is probably design really cheap and then just keep replacing them as they pop, right?
Oh, come on, that's not quality engineering.
That's pretty good, actually. I like that.
We can't give dodgy advice.
Yeah,
right.
Just
modular,
replaceable. Yeah, exactly.
Yeah. Well, in that case,
come on.
In something like this, I would.
Yeah, exactly.
I would actually consider a modular front end. Because if the front end if there's any potential for the front end to get fried, you don't want to be board level repairing your front end board, because that's a pain in the butt. If you can swap out like the input ADC module,
that's interesting. Richard, do you do any opto isolation or anything like that as well? I mean, obviously getting 10,000 volts of opto isolation as well is kind of tough, but
no isolation at all. So it's meant to be a pretty small device. And, so far tests have been okay, but it's too early on to have done significant testing around those voltages. It's kind of like closest I've got to the testing is like, a couple of meters away from it, and not really, willing to put my poor little prototype through the ropes just yet.
I can just picture you like having your device on the end of a 10-foot long wooden pole, and he's like nervously putting it closer and closer to the transformer.
Wearing like a full isolation suit.
Right. Okay. Oh, that's great. What do we? Come on, we've got to say more about this, Chris. We have to have more advice.
I have no more. I mean, I'm a little. I was actually surprised that we could say so much without being up close and personal. Like, I was worried that we're gonna have to be like, oh well, Richard, if you could just send us a scope plot, we'll just wait for that to come through, and then I do wonder about when that's gonna happen.
Yeah, should we do that? Should we have some sort of facility for people to? Well, I guess they can. They can just email us a image or something. If
feedback at theamphour.com
takes time. But that takes
all the IP
that doesn't make for good live radio.
Yeah.
So how many of these are you making? Is it just like a one-off?
Small volume initially, like probably the next 10 to 25-ish units, and see where it goes from there. Low volume initially. Right now I've been hand assembling everything, reflow and so on, but hopefully over time it increases.
Yep.
But it's definitely not urgent to get to market or anything like that, at least mass market of any form.
The benefit and also disadvantage of low volume. I'll start with the benefit of low volume production, kind of testing stuff, like this, in the dozens, is that you often don't, you don't have a significant number in order to turn up your more obscure faults, in order to show up more obscure failure modes and things like that. So you can often get away with it. You make 10 of something and they might work fine for years and you think this is rock stable. It's because you don't have a high enough sample group, for things to go wrong often, right? Whereas, which can be a good thing, right? Because, hey, you can, job done, wipe your hands of it, right? And excellent. Big tick on my performance review, at the end of the year, right? And
that's what counts.
But if you do high volume stuff, then of course you get all these significant numbers, but unfortunately you only find out until you've actually produced, 10,000 of them, and then you find, oh, geez, Mark, I'm getting a 2% failure rate. That's not acceptable. Yeah, exactly, recall time, and that's a world of hurt. But the good thing is it makes a more robust product in the long run. So if your goal is ultimately, if you've got a 10-year lifespan product, you don't want to be making 10. You really want to be making 10,000 and flesh out all the problems. But yeah. But that can be embarrassing, if there's a large failure rate. So those annoying ones is where you're not sure why. I can imagine this being one of the scenarios where, you get a report back from somebody in the field, you've made 20 of them, oh, it failed. And you get it back and you go, well, okay, yep, why? And without actually having sensors and everything in place in your actual test, the real test scenario, you can't tell. You can't tell what caused the failure often, and that can be you can be chasing your tail forever. It's not like something like this when you're right next to a substation transformer. You can't just walk up for a multimeter and start probing around.
Our initial test units will actually have a bit of sort of data logging in them to send us back some data that's been gathered on how they're being used and what kind of signals we're picking up.
Smart
and hopefully if they don't explode and catch fire, send us any faults. But you never
I was going to say, what if the data that's sent back is just, ow, stop it. Why is this such high voltage? You're mean.
There's actually, I'm judging the Hackaday Prize at the moment. Sorry for the little segue. Judging the Hackaday Prize at the moment, and there's this project in there where it actually generates a human voice and actually sends it back via RF, so you can listen on an actual radio, so you can actually hear it. It's talking, sensor at 102% alert. It's great.
Yeah, that's awesome.
I think we should incorporate voice into our products more.
Oh,
You get these cool voice chips now,
Well, we're past Back to the Future Day. Isn't that what we're supposed to be at? Everything speaks to us, and you've got computer that you just say computer.
That's right.
Exactly.
That's right.
And
Computer.
everything speaks like Max Headroom,
Yeah.
from the Cafe 80s. Sorry, if you don't know the scene.
I remember, I think I mentioned on the show before, but I was always really keen on the idea of putting that into test equipment. I tried pitching that when I was at Keithley, because you think about when your head's down on a board, say you're not even working high voltage.
Yeah, trying to probe around. And...
Exactly, what the reading is, and if you don't have
Actually,
that, you're kind of...
I've seen some multimeters that do have that. They'll read out aloud the voltage reading. So not on any scopes or anything.
Yes.
I've seen that in
they do.
some multimeters somewhere.
Oh,
There's
okay.
a couple of them. Yep.
Well, then maybe I'm wrong.
It's a very niche thing. You've got to want to.
Maybe someone was listening
that,
to the show and they were like, done.
Yeah, right. That's how it's done. Yeah. We're like Shark Tank in reverse.
Right. Well, have we answered your question, Richard?
Yeah.
Kinda,
You
sorta,
definitely
not really.
relieved some of my concerns, and I'll
Yeah,
let you know how it
I
goes.
think she'll be right. Is my official Aussie response. She'll be right, mate. No worries.
Sounds great.
So you're actually Canadian?
I'm Australian, but I've been living in Canada for a long time now.
I thought so. I thought that was an Australian accent, but I wasn't sure because of the poor voice quality of this connection. I thought, from your first time you spoke, I thought Australian. What?
Yeah, Adelaide.
Sleepy Adelaide.
Yeah. How's that, Chris? You're surrounded by it.
That's okay, man. I've gotten used to it. So.
Alrighty. Thanks for the call.
Yeah.
All right. Well, yeah. Thanks, Richard. You're
Thanks,
number
Richard.
one. You could be the
awesome.
last.
Hopefully. Oh, God. Well, hopefully more call up and get through, and I look forward to listening.
If not, we'll do our usual BS that we do every week, so we'll be fine.
Yep, we'll be fine. Awesome.
Thanks for calling in.
Thanks, Richard, for being
No
the
worries.
first guinea pig.
Awesome. Cheers.
See you, mate.
Bye.
All right, well, that was good. Man.
That worked. And the delay, there was hardly any delay there. So I think Gary's, it could be something to do with his connection. Might be
I was
delayed
getting a little bit of delay, but yeah, that's...
Oh, really? Okay. It seemed
Insider
pretty good
baseball.
to me.
That's okay.
It was quite small.
Yeah. So you still haven't ever listened to Car Talk, have you? Right?
I when you first told me about it, I went and had a listen, and it's like just so not what I'm interested in. So,
see, that's the thing. Those guys were troubleshooters, though. That's what's amazing about it. Like, and it's like pattern recognition.
You've got to listen
stuff
to
like
the
that.
whole show. Yeah, you've got to listen to probably a couple of shows to get the feel for it. And I wasn't, I'm not a big podcast listener.
Right.
So,
Exactly. So so that's definitely one thing.
Sean on Twitter is asking, "Are we doing a live show?" Yes.
Well, sort of. Not really.
Well, we are.
Yeah.
I'll call in and find out.
So the thing that I was going to mention, though, is that on Car Talk, those guys do something called Stump the Chumps, and they would call back in like later, and they would see if they were right. So
yeah, right.
I don't know if we'll be able to do that with Richard, though, because he might be
6 months
10,000
down the
volt.
track, we'll have to call back and say, yeah, every 10% of them just blew up, like.
Yeah. Or, well, I mean, if he blew up, though, that's the problem. That's the real issue.
I mean, see, here's the thing. Like, you want to give advice for something like this, but my first gut reaction when he told us, he's putting a sensor next to it and it's floating next to a power transformer, it's like, you'll be fine, no wuckers.
Yeah.
So, but that's not really, that's not really solid engineering advice, is it?
It's not. I mean, the things I think about are like capacitance between the power and ground type of things. If you could have those transients just even between, small transients between the board, if there's a big enough drop, that kind of thing. Like, I don't know if that's if that would actually happen, but floating electronics is awesome. It's just super hard to. Actually, the tough part is measuring, because almost every scope and every bench DMM, you have to get everything handheld, because any kind of ground reference piece of test equipment.
Oh, yeah, mains earth reference, yeah.
You will ruin.
Yeah, I've done a video on that, how not to blow up your oscilloscope, and people, I don't blame them, people still have a hard time understanding the concept of what's going on there.
Yeah, right.
And you've got to think about the whole system and where current is flowing and, references and how, ground isn't ground and, or ground can be anything you want it to be. And, like we do have a couple of more callers.
We do. So let's welcome Arsenio.
Arsenio.
How you doing?
Hello, Arsenio.
Hey, Dave.
G'day.
All right, so I'm having a problem with these. G'day. All right, so I'm having problems with these I2C lines.
Yeah.
So they keep pulling low for some reason. I don't know why.
Oh.
What are they connected to?
They're connected to Arduino and an IMU. They're currently connected in my rocket stabilization system prototype.
Whoa. Okay. We might need a link to that eventually because that sounds awesome.
So you're saying
that a while back.
Okay.
All right. So you're saying that they're pulling low even when they're not supposed to be communicating. Is that what you're saying?
Yeah, that's correct.
Yeah.
So
okay, is it?
I've checked on my crappy logic analyzer, and it shows that there's a packet ping, and then it just doesn't respond. I'm like, well, that's weird. So I disconnect the logic analyzer. I run it again. It queries. About 80% of the time, it responds. But the other 20% of the time, it doesn't respond.
Oh, I squared C is... I like it, but it can be a pain in the ass to troubleshoot sometimes. Well, what's your is your IMU?
I'm debating whether I should go with I2C or SPI, or is it SPI? I don't know.
SPI, SPI.
Yeah, either's fine,
some people like to call it. Yep. I mean, SPI is more robust. I2C, you've got the capacitance of the line. If you don't choose your correct pull-up resistor, you can get interference, blah, blah, blah. It isn't as robust as a good, solid totem pole output SPI driver. Boom, there it is. None of this pull-up rubbish.
Well, that's a new one. I've never heard it described as a totem pole.
Well, SPI is all digital outputs are totem pole outputs. So that means they have a driver and two output transistors. One pulls it high and one pulls it low. Whereas I2C is the opposite. I2C is an open collector output, essentially. And to pull the line high, you're relying on that pull-up resistor. So your pull-up edge, if you actually have a look on this on your scope, probe the line and zoom right in on the edge, and you'll see that it'll pull down very quickly. It'll pull down like almost instantaneously, right? Because there's a transistor there to pull it down.
I don't have a scope.
Oh!
We found the first step. No,
there you go.
That is a big step. I mean, it really is.
Yep.
It is a big step.
Yeah. That's the other thing. A lot of
Zero
problems...
budget here. Using
a lot of I2C problems come down to you've chosen the wrong pull-up resistor value. What value are you using?
Right now, I'm currently switching between a 10K and a 5K. Neither work too well. I was advised to use 10K. I was like, let's try 5K. Didn't work.
I'd probably lower that.
What should I be using?
Yeah, I believe the sort of like the industry standard value is 2K. That's recommended. But you can even lower it down to a K. Lower it down to 1K and see if it makes a difference.
Do you understand the relationship too with the higher lower resistance and how that ends up affecting the whole circuit overall?
To the most extent, yes, but I'm still pretty fuzzy on it because I'm doing this with very, very little actual knowledge.
Okay.
Right.
It's more or less futzing about with it to get it to work.
Yeah, no, that's understandable. I mean, so the main thing is that so the idea of a pull up or a pull down is basically using the rail or using ground to inject current. So that if you think about it as, so you said you're using Arduino, like Dave said, it's an open collector. So what's happening there is really all it's doing is usually tugging down. And you have a pull-up resistor there is so that when the Arduino is no longer pulling down, instead of the voltage drifting higher and higher just because of, just leakage currents or anything like that, what you do is basically you have this pull-up resistor contributing current from the power rail, but you don't want to have it actually shorted to the power rail. You want to have, some kind of controlled amount of current being injected into that line, and that helps to bring that voltage up quicker. So a lower resistance for the pull-up resistor ultimately ends up injecting more current.
Yes.
So
which is better? So a lower value pull-up resistor, the better it is, and the faster it's going to pull it up.
Right.
So the less timing issues you might have, or something like that.
And the trade-off there too is that the reason people use higher values in the first place is power, right? Because if you think about it, if you're using like a super low power device, and you could use a 10 ohm resistor if you wanted to, it would be, but then you end up dumping a ton of current into there through that pull-up resistor, and either you're going to burn a bunch of power directly, or you're just going to burn your battery out because you're going to be using so much current in order to simply raise a lineup. So usually it's a higher value, like 2K, 5K, 10K type of thing. So yeah.
But something like the SPI bus, you really should get a scope. It'll really tell you what's going on there.
Yeah, on my to-be-it list.
Yeah, that is a big one.
All right, so another thing is, I had a strange bug that I fixed by changing the baud rate from 3200 to 115200. What was happening was it either randomly froze up with the FIFO bus overflowing, or it did what I call the Harlem Shake glitch, where even though the sensor was absolutely still and the silicon had come up to temperature, it just spewed random values like it was turning itself inside out and flipping like a doomed progress ship.
Very illustrative. You have a gift with words, my friend.
Thank you.
Yeah. I am allergic to phrases like what did you call it? Like it had a bunch of noise, or it. What was how did you say it at first?
No, it just put itself inside out.
Yeah.
Wait, the first one?
Yeah, the first.
Oh, that was a FIFO overflow for some reason.
Yeah.
But increasing the baud rate fixed it. I don't know why.
That one's kind of tough to troubleshoot with.
That's like a software. Yeah, that's a library issue. How your comms library is written and how it clears the FIFO. How it actually clears the buffer and all that sort of jazz.
I think another thing to point out is if you're not setting the baud rate the same on either side, you start to basically, you're not. So basically, with a serial link like that, it's expecting data at a certain rate, and if it doesn't get that, then it's all just going to be garbled packets in the first place. So that would be a big part of it.
So do you have the opportunity to change to a SPI bus for this sensor?
Yes, I do. It's currently all on just breadboards and protoboards right now. I'm moving towards actual PCBs.
Yeah, that's the other thing. When you've got things, when you've got breadboards and wires hanging everywhere, you've got capacitance and you've got a big antenna, basically. And when you've got an I2C, that is not ideal for an I2C line. That's why you want to have a lower value. Whereas an SPI line, as I mentioned, is a direct drive totem pole output. So you've got no issues with pull up, pull down. You don't need them. You don't need a pull up resistor on a SPI line because it's just driving directly. And
that's
it's
true.
I mean,
that might be a bit of a red
solid.
herring, I think, in general, though.
It could be.
There's tons of potential issues. I mean, there's addressing, stuff like that with I2C. There's tons of issues like that.
Yeah.
There's a lot of good tutorials out online. Actually, my friend Dan over at Rheingold Heavy does a pretty good I2C SPI set of tutorials. We can put a link to that in the show notes. But
yeah, I've been reading some stuff recently.
Okay.
Well, if I build up something and an I2C line doesn't work, right, and I'm sitting there scratching my head, why doesn't it work? The first thing I'm going to do is actually get the scope out and just probe it to make sure that there's nothing funny with the pull up or anything like that. That the edges are nice and clean and everything's talking. And then after you've checked that, then you go into the chip addressing. Is the chip being addressed? Is it enabled? All that sort of jazz. And then you get into the protocol. Well, is this a proven I2C library? Have I used it before, or did I download it off the internet and I've got no idea if it works?
Yeah, and if you use like a Salier type of thing, or there's a lot of them out there, but you can actually do the translation in the logic analyzer a lot of times too, and that is just magic.
Yeah, I've got the TiVo $10 clone one.
Okay.
Oh, okay, right.
I feel kind of guilty about getting it right now.
Mark and Joe are
Further on
mad
down
at
the
you, I'm
line,
sure,
I'll go and get an actual.
Well, as long as you go legit later, then
I'm intending to get a real one further down the line.
right.
Exactly.
Excellent. Then that's I think that's fine. Then.
Future customers. Yep.
Yep.
Cool.
Yep.
Well,
It's all
Arsenio,
good.
thanks so much for calling in. We really appreciate it. We got another call, but good luck with
We
those
hope we
issues,
help.
and let us know how stuff
All right,
goes.
I'll link you guys to my project on Twitter. All right, we'll keep you posted. Thanks for having me on.
Thanks.
Thanks, mate. See ya. This is working, Chris.
It's kind of working. Yeah.
That Arsenio's voice quality there was a bit dodgy, though.
See, I thought it was okay. I don't know.
codec?
Yeah, I guess.
Oh, okay. No, it sounded very.
We love feedback. People can leave stuff in the comments. I'm going to clean some of this stuff up in post, I'm sure. But yeah. Let's welcome our next caller. We may have a voice that we recognize here. Hello, you're on the Amp Hour.
Hey, Chris. Hey, Dave. This is Brandon Harris.
Our
Hey,
former
Brandon.
guest from the Electric
Yes.
Imp. How you doing, man?
Good. Good. How are you guys?
Good.
Well, we're surviving. People are calling in, which is good.
Yeah.
For our first call-in show. It would have been really embarrassing if we're just sitting here going, nobody's
Right.
calling.
What people don't know is we begged Brandon to call in or something, right?
Right, yeah.
Please call us again.
This strays a little bit outside of strictly hardware and more into sort of culture and thought leadership. One of the big things that's happened in software with security things is the notion of responsible disclosure. And I was kind of wondering what you guys think of that in terms of how it translates to hardware engineers, because we're increasingly getting to the point where, hardware is a significant part of the security story, whether it's even in some cases very simple things, a garage door opener, up to very complex things and IoT-enabled things. And whether, as hardware engineers, we have a responsibility to disclose that to a manufacturer rather than choosing to publish that on today and, sort of pull their pants down in public.
Right. Okay. So you're talking about there's sort of isn't there like a sort of unwritten rule in the security hacking world that if you find a hack to a product, let's say you figured out how to hack some sort of, the new
car.
credit cards or something, or a car or something.
Good example.
Would you, you're supposed to contact the manufacturer first and give them, 2 weeks to respond or something? And if they don't, then you go public. Is that what you're talking about?
Yeah. So, for example, I not so long ago spent some time reverse engineering a product and found that the hardware, the wireless protocol they use is wildly insecure, right? And there are people doing things like putting front door locks on this and using it for garage door openers and things like that. And do I have an obligation of one disclosing that to that manufacturer? And, do I have an obligation to not publish it until I give them a chance to respond? And it's obviously different with hardware and software because, in software, if I find a bug on a server, they can go fix it. But they may not be able to come out and fix it.
Right. Hardware is tough. Yeah. Well, so do you see the cynic in me, right? Me, cynical. Who would have thought? The cynic in me would always think that if I go tell the manufacturer, they're just going to sweep it under the carpet. They're not going to say a damn thing. It's almost as if I would be inclined to, you would have to threaten them. It's like, if you don't, I'm reporting to this, I'm giving you an opportunity to respond, but if you don't, I'm going public and I've got 280,000 YouTube subscribers and you're going to be toast, dude.
Pay me.
As somebody who's worked in large companies like this and seen things being swept under the carpet, I mean, it's just a company's natural response, especially, as you said, because they can't easily fix it, right? They can fix software. Oh, yeah, patch, right? Done. Send it out, right? Fixed. Not a problem. But hardware, how do you, it's got to be a case-by-case basis, doesn't it?
Disclosing it may hurt the public in general, right? That it may help.
It could
some
hurt
people
the public
because they can
and
say,
the company. Yeah.
And so it's it's kind of a moral dilemma, right? That software is fairly well defined, and I thought you guys might have some thoughts to share with the community.
Well, I am not a sweep under the carpet guy. I'm going to stand in the camp of, well, it's there. Don't sweep it under. It's going to come out eventually. You might as well do it and fix it. I don't care how much pain it's going to cause.
Well, I think there's an interesting piece there. I mean, so this has existed for a long time, right? I mean, but it usually exists more. It's more front loaded. Feels like. Because, this is what errata is. If you have a new piece of silicon and you're willing to use a new piece of silicon that is not, battle-tested by hundreds of engineers, then, you're going to be you might be potentially discovering silicon errata, right? And that's the idea, and that's what errata notices are for. I don't know. That's, at that point, do you at least turn to your coworker and you're like, hey, I wouldn't use that chip? That's kind of risky.
Yeah, but a chip, it's not a product, is it? That's the difference. I think there's quite a potential bit of difference there between reporting a bug in a chip and reporting a product as such that consumers, Joe Average, might be using.
Yeah.
And that hackers can take advantage of. If there's an errata in a chip, it's that's companies should have tested their own products who built with that chip, should have tested their own products to make sure it works, and it's probably not a problem for them because they've tested it, right?
Yeah.
So it's less of an impact.
To play devil's advocate, at Electric Imp, we are, we start with security at the hardware level, and we can test a chip to verify that it is secure in the ways that they say it is. But, actually comprehensive, security validation and there's a buffer overflow in the bootloader, right, that can be executed, right? I mean, this is something we also dealt with at Apple where, everybody and their mother is trying to jailbreak an iPhone. Whether it's hardware or software, right? You're still beholden to these, insane cases. In some cases, the manufacturer may be able to mitigate it. In some cases, they can't. But, it's kind of to say that, Apple surely can test, all of their software and all of their chips, and yet the iPhones are typically jailbroken, right? It's kind of, it trivializes the problem to say, you should just test your product.
Can I put you on the spot here? Because you called in.
Got him. We got him, folks.
Yes. And being a manufacturer of a product like this, I don't know if the security things in the imp itself. But let's say, okay, you've manufactured your 1 million imps, right? And they're gone out there. Everyone's using them. And someone found a security flaw in it that makes it possible for anyone to hack into any secure electric imp anywhere. And this could potentially be a massive recall for you. As the manufacturer, what would you think? Would you thank them? Oh, thank you. Or would you go, oh, shit, we're going out of business. I'm going to sue this guy, for actually releasing this.
Yeah, there's there is a legal issue there. I'm sure it's almost like a libel type thing, right? I mean, it's almost like that.
It's almost libel, yeah, potentially.
Yeah, I mean,
well, you can be sued at any point for anything. So if you did this to a big company, right? Anyway, sorry, go ahead.
I can't speak from Electric Imp's standpoint. I can speak from mine and what I would expect Electric Imp to do. I think I agree, right? You have to step up and, put on your big boy pants and own up to your mistakes, right? That's part of it.
Right.
We've spent a tremendous number of hours working on it, protecting our system. It's something that, we consider part of our core philosophy. We've hopefully, we also do things preemptively. I did work at Apple.
Yeah.
My expectation is that no matter what I do, somebody will find a hole in it what you need to have sort of, we talk about like layers
Correct.
of the onion, right? And so in some cases you can play the cat and mouse game where it's like, okay, well, I can make this hard enough for somebody that, it's not worth their time. And maybe at one of those steps, I block them completely, right? So you always have multiple levels of security. And, we would have to look at those things. But absolutely. Like it keeps me up at night, right? Like, it would be devastating. It would be, I would
of course
think
it would,
extremely personal, that it would feel like a failing.
But that's a risk, isn't it? Yeah, of being in the business that involves security, any form of security like that, you can't even your best intentions. You could test it until the cows come home, but nothing's 100% testable. Somebody might always find a flaw. I mean that is a risk of being in that business.
The phrase we use a lot around here is there's no such thing as a secure system. There's a system that is secure at a point in time. And everybody thought their servers. Everyone thought their servers were secure and that they had all the latest SSL updates. And it turns out they all had a massive heartbleed, bug, and nobody found it. Nobody knew.
Oh yeah,
about
I remember
it.
that.
Say, it was super tested, but banks and stuff had huge holes in their security, and they've been running that way for months, and nobody had caught it. And it was great to see the community respond. That thing got announced. And there were patches day one, and servers were being rolled. It was great to see that level of response. But it's true that you can't design a system that is secure today and secure in the future, right? You can do the best you can today, and you have to give yourself the tools to improve it in the future.
Cool.
I've got nothing more to add.
Unfortunately, I think, Brandon, unfortunately, the security side of things, it's like, I don't know, how much is hardware really at the security level as well? I think about it, like I mentioned, Errata, but security, there's encryption level. If the silicon's busted for the encryption, part of the chip, it's like, I don't know, man. That's like a recall at that point. That would be totally worthless, right? Is there any fixing that? If it's spitting out bad hashes?
There are certain things that there's no fixing, right? But things like, we're getting more and more tools like the chip whisperer is a great example. That's another one of those things where it's like, your design is secure today because nobody can look at, nobody can capture the power line traces, but all of a sudden the chip whisperer comes to market and everybody and their brother can start doing, power band analysis and all these side channel attacks, and your security breaks down. The people who are going to be doing those attacks are going to be hardware engineers, right? The only people that understand that stuff enough, are going to be hardware, and with some software, but that's the kind of direction that I think most hardware engineers are moving now, right? Even you're designing microcontrollers and writing software
anymore.
and stuff.
In the past, it has required hardware knowledge to do that, but now if you can buy a chip whisperer off the shelf, you can have no hardware knowledge and still potentially, or little hardware knowledge and still potentially, do these sort of attacks.
And it's up to the hardware engineers to try and prevent them and fix them, right? But they get.
Yeah, I think the best people that are preventing it are trying all this stuff themselves. They're white hat type hacking, that kind of thing, right? They're testing their own products like that.
Yeah.
All right. Well, thanks, Brandon. I think we're going to have to.
Sorry, we don't have more, man.
Nice to talk to you again.
Yeah. Well,
thanks, guys. Interesting topic.
It was a little outside the hardware realm.
Cool.
Yeah, that's good though.
Thanks
I think
for that, mate.
That's definitely a good topic, and I'm sure we'll get some good comments in the comment section. And people can always write feedback at theamphour.com.
Yeah. Good luck with the rest of the show.
Thanks, man.
Thanks, mate.
Bye, guys.
See ya. That was
All right.
interesting.
Yeah.
And we've got another caller. They're coming thick and fast. This might be our last caller.
I think it might be, yeah. So let's pick up with Steve from LA, and he's wondering, how do youngsters get started without using SMD parts, especially as they get more common? Steve, welcome to the show.
Hey, Chris. Hey, Dave. How's it going?
Hey, Steve. Good, mate. What sort of accent can I hear there?
Oh, no, I'm just from Los Angeles, so I'm a Californian.
Californian, yep, right.
So you guys were talking about the demise of the through-hole parts. And I teach a science class for 3rd and 4th graders, and we use through-hole parts, occasionally and whatnot. And what happens if they all go away? What are we going to learn from? Surface mount?
They're not going away. Through-hole parts are not going away. They still have their place. It's, people have been saying that for 20 years, but it hasn't happened. And there's no signs of it happening. So, I don't like it. Yeah, it's getting less and less, but there's still hundreds of thousands of them out there. So I don't think it's a major concern.
Do you think it's, I guess one thing is that you're always going to be able to find new old stock type of thing, right? Just because of the scale of the industry. So that'll definitely help. And I think that even it's still cost effective on some levels to do, through-hole resistors, or there's power requirements that require through-hole resistors and stuff like that. I think really it's the newer, more advanced chips, but in those cases, if you're getting started, you're not going to be jumping right into doing like the 5 amp buck boost or something like that. You're going to be starting a little bit smaller, and
exactly
555 stuff like that. You're going to, they're making tons of money on those parts. They're, it costs $0.01 to make and they sell it for $5. It's like, okay, well, they're still making a healthy margin there if you make it up in volume, right?
Yeah, because I started out when I was like 9 years old, and we just make airborne circuits and things were so easy. But now if I have controllers and stuff that I want to use, if I actually go with the Teensy and stuff like that have that they're actually needed, so we can actually still have access to those boards and stuff. So I don't know, it's just a thought. It was so easy to learn when you had circuits flying out in the air and soldering and whatnot. It's just easier than for youngsters.
Yeah. Well, you can still do it, but there's, so many, but there's so much more advanced stuff these days, which is only available in SMD, as Chris mentioned.
Yeah.
And that's just, that's just the way it is. But, there's still infinite amount of stuff you can learn with through-hole parts. So, yeah, sure, you can't get an accelerometer, for example, in anything but one of those pain-in-the-ass leadless
DFN
chip carriers, right? But, hey, but for a couple of bucks on eBay, you can buy one. Somebody's already soldered onto a DIP adapter and plug it straight in. Just plug it straight into your breadboard or wire it into it. I mean, so there's always going to be the...
10 years, all this stuff is still going to be around?
Yep. I bet your life on it. Bet your life on it.
All right.
Yep. Like if you go, can you go to DigiKey now and search for all through-hole parts? You probably can in terms of chips, right? Go there and just search how many are available in a DIP package, for example, and you'll probably get tens of thousands.
Parts.io.
No, Parts.io. All right, Mr. Parts.io company man. Right? There's tens of thousands, and 10 years ago, for example, there were still tens of thousands. Like, it's dropped a little bit, but I don't really, no, I can't see it suddenly vanishing and dropping off the cliff in 5 to 10 years' time. Not going to happen. Don't worry. No worries. She'll be right. That's the second time I've said that in today's show.
All right. Very good.
That's my answer for everyone.
Cool. Thanks for calling in, Steve. We appreciate it.
Thanks, Steve.
All right, Chris. Great. Bye.
All right. Well.
And we don't really have any more, do we?
No, but that's okay. This is our
There's
first time.
There's an anonymous caller, but...
No, that's Gary.
No
that's our screener.
Oh, that's...
Yeah.
Oh, sorry, screening room, right.
Yeah.
Okay. Sorry, I'm still getting used to this software.
So, what do you think, Dave? I mean, should we do this again? I mean,
well, it's worked. We had no crazy people call in.
Yeah,
well,
what's
maybe
up with
we
that?
did, and Gary gave him the boot.
Yeah, that'd be good.
Yes.
Yeah, I think these were all actually really good questions and everything too. Like easily describable issues, stuff like that. Actually, I just saw Phil Frieden, one of the other Frieden, sorry, the former guest, was making a joke on Twitter about if there's like really hard to describe conditions, then it's not going to work as well. But if there's a lot of it's going to be kind of us talking about basics like pull-up resistors, stuff like that. I think that's good though, because it's the stuff that you and I might not talk about on a normal basis,
right?
But a lot of people have a question about, so that actually works out really well.
Well, I expect most questions from beginners, like as who was it? Richard? No, the Arsenio, right? Yeah. With his I2C pull-up, it didn't have a scope. right?
Right.
It's like kind of, that's where I expect the majority of questions to come from.
Yeah. Right.
Rather than, experienced industry guys and, I've got this, 1,000-pin BGA and I'm doing DDR5 SRAM and I'm having issues with,
it's pin G11. Just fix that one. That's the answer. Yep.
Right. Yeah, I don't expect too many of those. But I like the spontaneous nature of it. People get our first gut reaction to questions.
What Dave likes is not having to prepare. That's what he's trying to say.
I do enjoy not preparing. Well, it changes things. Like if we had a bunch of questions, it'd change the whole look and feel of the show. Change the whole feel of the show. Because we'd have prepared answers that we'd want to go through, and like it just it might be a bit more accurate and
people are always in all this accuracy
so
and right answers.
I know, but it's not fun.
Yeah.
I think the spontaneous nature is good. People get our gut reaction to things.
Yeah, I think next time we'll try and make it a little bit quicker. The response time is probably the big thing. So, but
what, as in us answering the question?
No. I mean like the delay in the line. That's just because it's all soft. If we switch over to a hardware solution, and I do have one person that might be Charles might have said he could help us with that, so we might be able to do that eventually.
Oh, okay.
So.
Geez, we've only used Call in Studio once, and you're looking to ditch it? What?
Maybe.
It seems to work, but yeah, I mean, it's always going to be dependent upon the phone quality at the other end.
Right.
Or what they're using. Are they using a direct landline? Are they using Skype in Timbuktu?
Yeah, man.
So, but anyway, it worked.
Yeah. I don't think we'll be doing this every show. I'll tell you that.
No.
This will be this is a sometimes food,
Right. Junk food.
Right, exactly. Yeah. So I think next week we'll be back just doing our normal thing. I'll be heading I'm going out to the conference next weekend. So
which conference? Oh, the Hackaday conference where they are announcing the winners to Hackaday.
That's right. Yeah, and you are off to finish your judging right now. You said, right?
I'm finished. Yeah, Sophie's pestering me. When are you going to finish the results? Right after this show. So it's your fault, Chris. For
it's my fault.
interrupting.
Yep, she'll yell at me.
Yep.
That's fine.
Yep.
That's good. Yeah, no, that's exciting, and I think there'll be a lot of familiar faces out there, so I'm looking forward to that.
Can I mention something about the Hackaday judging?
Sure.
It's I've got to give a score. I've got as the other judges have. How many judges are there? There's like 8.
I think there's more this year, like 12 maybe.
More 12. Okay, yeah, there's a lot of judges. Anyway, we've got a rank. We've all gotten I believe. Correct me if I'm wrong, Chris. We've all gotten the top 10, right? So there's top 10
right.
projects.
I don't know.
Pretty sure it is. Anyway, it wasn't in the first rounds because we all got like different groups of projects. Anyway, we've all got the top 10 and we have to rank them from 1 to 10, 1 being the worst, 10 being the best, in various categories, right? So,
like documentation and technical ability, that kind of stuff.
How open is the product, for example, is a tough one, right? How open is the product? And and I feel bad because I've got to rank one of them 1 out of 10.
Oh, no way, man! That is why you do rank systems. Otherwise, you get. You ever done a gauge R&R before? You know what that is? The gauge R&R is like if you had like 4 test stands, and like 3 of them were spot on perfect. You're like 3 calibration stands, 4 calibration stands. 3 of them are spot on perfect, and then one of them is just skewed higher. Gauge R&R is basically how you can compare all 4 of those and then just determine, test stand 4 is actually just higher. So the tying back to this thing would be, if you and I are judging something and then there's a third person and you and I are centered around 5, right? All of our scores are centered around 5. Another person's centered around 8. You're basically like railing that op-amp judging. You know what I mean? Like you have compression of the actual judging numbers. So that's why ranking's great. Full dynamic range.
Oh, I totally agree. Full dynamic range. But in some cases, like as I said, like the open thing, right? They're all open. I mean, that's a definition of they have to be to get in the contest, right? They've got to be open. So how open are they? Well, like, you know, like there's one or two standouts by, like I'm going to judge more, like if you've put more documentation into it.
Yeah,
you know,
right,
if you've got
just
more
really
documentation,
good.
then you're more open in quote marks. So I'm going to rank you higher, right? If you've got more documentation, you're not necessarily more open in the legal sense, right?
Oh,
you're exactly the same as everyone else. You use the same license, blah blah blah, right? But you're providing more information. So you know, but yeah, there's like 5 of them in there that are like almost equal. Like, so I've just got to like, yeah. It's tough.
Sorry, man.
It's tough.
Yeah.
I know.
The life of the guy who's just passing judgment. It's, it's tough.
Yeah. Anyway. But it's good. They're all great projects.
Oh, yeah, man.
So,
I'm always impressed by people doing that stuff, so.
Yep. The amount of work they put in is fantastic. Some really good ones. Anyway, so I'm going to do that now.
Okay, cool. Well, should we call this a success? Is this a success?
I think, it worked. Nothing went wrong, really.
Marginal success. Woo!
Yay!
Cool.
And that's what we do best here on the Amp Hour.
That's right. Mediocrity.
And we are officially in the podcast universe.
Oh, yeah. I should post that map. That's right. Someone
you
made a
should
map
post
of
the
all the
map.
different podcasts and stuff.
We are on there.
Yeah.
I didn't see it at first. We are buried away. And
Yep.
I have influenced nobody else. But you're an influencer, Chris.
Oh, yeah, because I started the Engineering Commons and don't do it anymore.
Yeah. So it's a map of how all the podcasts are linked.
Yeah.
You know. So, yeah. By the people
it's nice, too, because you
them.
can find other podcasts, that kind of thing. So.
Yeah, it's very handy.
Post a link to that.
We're on there. Yay!
Cool. All right, man. Well, talk to you next week. Good luck with judging.
See ya.